Hey, do you like multiplication?
Maybe. Is that okay?
Yeah, it's cool. I like math.
Cool.
Okay, hello everyone. Let's welcome to the video solution of this week's quiz. So let's look at this is a version A. Let's look at the first question. So you asked us to find out the standard form, right? So before we find out the standard form, we can look at our notes, right? We can look at our notes and we will know that a standard form is the form that is written in f of x or y is equal to ax squared plus bx plus c. This is standard form, right? And then we have the factor form. Factor form, we can write f of x is equal to a times x minus p times x minus q. Right, and then we have vertex form. So vertex form is, we can write it to fx is equal to a times x minus h squared plus k. Or so if you know those three forms, then you can see, okay, which one is in this form, and you will find out, okay, it's f. Okay, or you can tell whether it's standard form, factor form, or vector form, vertex form, by finding out how many parentheses in each form. For example, standard form we have 0 parentheses. In factor form we have 2 parentheses. In vertex form we have 1 parenthesis, right? So this is another way to find out that. And since it's a standard form, you see only in this one, f, doesn't have any parentheses. So that should be f here. Or we can relate to some properties of each form. For example, that standard form tells us about the y-intercept. So which means if you take 0, x is equal to 0, where you want to find f of 0, you can easily get f of 0 is equal to c, because it is given from the standard form over here. So it's related to the property standard form tells us about y-intercept, okay? And y-intercepts, factor form. So what does factor form tells us about? Factor form tells us about the 2 roots, right? The 2 roots of the quadratic function. So which means if we set f of our x-intercept, so if we set fx is equal to a times x minus p times x minus q, the x-intercept, let it to be 0, and p and q are the x-intercept. So this is the x-intercept, right? And then the vertex form, okay, tells us the information about the vertex. How could it tells us the information about vertex? That's because x minus h squared, the square must be greater than or equal to 0, right? So by multiply with a, it's either like greater than k, greater than or equal to a, or less than or equal to k, right? So that's why vertex form tells us the information about the vertex, where we can see the max or mean, okay, minimum. So, okay, look at this one. So which one is represented by this parabola, okay? So first of all, we can tell, okay, from the information over here, we can tell the 2 roots, right? The x-intercept here is actually 1 and 5. So then, if we put this into the factor form, that's x minus 1 and x minus 5. You see that because the 2 x-intercept is 1 and 5, so it's x minus p times x minus q. And then another point we can find here is this point over here. You see that the y-intercept. The y-intercept is actually 0, 10, right? 0, 10. So 0, 10, that's the y-intercept. So we get this y-intercept into this equation. So right now we have fx is equal to a times x minus 1 times x minus 5 from the two x-intercept we find, or two roots we find, right? So then we can get f of 0, which is a times 0 minus 1 times 0 minus 5, and that's 5, right? So it's 5a is equal to 10. So we can solve for this, okay? 5a is equal to 10. So divide 5 on both sides. So we get a is equal to 2. So that's why we know E is the correct answer here, okay? E is the correct answer here. And then looking at this question, question number 3, use the square root property to find out the solution of this one, okay? So you can tell on the left side that's a perfect square trinomial. So the perfect square trinomial means we can factor this to be x minus 6 square, or of course you can use the x box, right? You can find two numbers, when it's add together it's 36, and it's multiplied together it's minus 12, so you can find it's minus 6. Okay, so it's x minus 6 square. And on the right side, 64 is also a perfect square number. So 64 is actually a square, right? So we can take square roots on both sides now. So let's take the square root. So it's x minus 6 square, which is equal to plus or minus a, okay? Because we take square root on this side as well. And remember, we have the plus or minus sign over here, okay? So then we get x plus is equal to a square, okay? So then x minus 6 is equal to plus or minus a. So we have two options. So x is equal to 6 plus minus a. So it's either x is equal to 14 or x is equal to minus 2. So this is not right, this is not right, this is not right. So minus 2. The answer is A. Okay, you circle the answer A. Okay, and let's look at question number 4. Circle the correct answer. For A, for the quadratic formula, you need to use which form? Okay, the quadratic formula is actually derived from the standard form, because all of the parameters inside the quadratic formula are A, B, and C, right? A, B, and C are from the standard form. So that's option B. And for B, to find the max or mean, okay, maximum or minimum, max and minimum are taken from the standard form, right? Sorry, vertex form, right? So vertex form is actually this one, right? Vertex form is actually this one, 1 square, okay? Only one parenthesis, okay? Only one parenthesis. And to complete the square, we need to find b over 2 square, right? We need to, because b is, we are taking half of b, right? To complete the square, we want to find the b over 2 square. And then to find the solution or roots, we can just use the formula, right? Big formula. So that's how we get the solution or the roots. And for E, in a formula, x minus h squared plus k represents. So this is a vertex form, right? In vertex form, k represents the y value of the vertex, right? So the answer is this. And now we're gonna tell, okay, for f, for this function, determine the type and number of roots, right? So how do I know it has like the real roots or complex roots? We're gonna use the discriminant, right? So we know discriminant is the square root part of the big formula. Looking at this, so it's b squared minus 4ac, right? So we need to use this b squared minus 4ac. If b squared minus 4ac is greater than 0, it has 2 real roots, okay? 2 real roots. If b squared minus 4ac equals 0, it has 1 real root, or double roots, okay, which means the 2 real roots like overlaps. Or if b squared minus 4ac less than 0, no real roots, or no real solution. So which means you will have 2 complex roots, okay, 2 complex roots. So So what is the b squared minus 4ac in this case? So in this case, a is actually equal to 1, b is equal to 12, c is equal to minus 1. So b squared is actually 144 minus 4ac. So it's minus 1, 4 times 1 times minus 1. So this is 144 plus 4. So this is equal to 148. And of course, it's greater than 0, right? So that's two real irrational roots. Why is it irrational? Because square root of 148. 148 is not a perfect square number, right? Square root of 148, then it's irrational. So if this is not irrational, only if this number is a perfect square number, okay? Is a perfect square number. Okay, so then this question is asking us to do the CTS, completing a square. So how to do the completing a square? So we need to do the CTS, right? So we need to find out A is 1, B is minus 4, C is 7, right? And then we do the CTS. So CTS is trying to taking the half of the B value, right? Taking the half of the B value. So it's like minus 4 over 2 square. Okay, minus 4 over 2 square. So it's minus 2, right? So it's minus 2. So what does it mean? So we need to find like minus 2 square, so which is 4, which means we're gonna add 4 and minus 4 here, right? So it's so we can write gx is equal to x squared minus 4x and plus 4 and minus 4 and plus 7. So this is the way that we complete a square, right? So then this is the perfect square trinomial, okay, where you can do the x box. You will find out this is x minus 2 square and minus 4 plus 7 give us the positive 3, okay, so it's plus 3. So we get this. And
okay, so once you have it in vertex form, write the form above and below it. Your A is 1, then your subtraction sign is there, so H is 2, and your K is 3, so the vertex is 2 comma 3. I scored this one. If you did CTS correctly and got 4, I gave you 2 points. If you applied it correctly, I gave you a 3, meaning a positive 4 and a negative 4 because it adds to 0. If you kept it in vertex form, I gave you guys a 3.75 and it has no vertex. So that's how you would get the full credit.
this is the vertex form, okay? This is the vertex form. And then write an equation for the parabola below, okay? So from this equation, we can find 3 points here, right? It's minus 2, 0, and 3, comma, 0, and 3, comma, 6. So we got an x-intercepts and y-intercepts, right? So in this case, we're gonna use, of course, you can try to use standard form, but we want to use factored form first, okay? If we use factored form first, we can get, because we can use this x-intercepts directly, right? So y is equal to a times x minus 2 and times x minus 3. So y is actually equal to, or fx is actually equal to a times x plus 2 times x minus 3. And then we just need to put the y-intercept, okay, to put the y-intercept into this equation. So when x is 0, y is 6, right? So y is 6, so 6 is equal to a times 0 plus 2 times 0 minus 3, okay? So this is a positive 2, this is a negative 3. So positive 2 times negative 3 is negative 6, right? So we get 6 is equal to negative 6a. So we divide negative 6. So a is actually minus 1. Okay, a is actually minus 1. So then we get y is equal to f of x is equal to minus x plus 2 times x minus 3. Okay, but this is not the answer because this is still the factor form, right? We want a standard form, so we need to expand it, okay? So we get f of x is equal to minus x squared minus x minus 6. So it's x squared minus x squared plus x plus 6.
All right, to expand this out, I'm just going to multiply these two. That becomes x squared. You're multiplying here. And then I'm going to combine like terms, so that's negative x minus 6. Don't forget you have the negative, so we're going to have to distribute the negative. And that's how we get negative x squared plus x plus 6 as your answer. If you solve for the a value, you got 3 points. If you kept it in factored form here, I gave you 3.5 points.
Okay, and then let's look at the last one, using the quadratic formula to solve that, right? What is the quadratic formula? When you use quadratic formula, first thing is you write a, b, and c, right? A is 5, b is minus 3, c is 1. And then write down the quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac over 2a, right? Over 2a. And you get those values into the formula. So then you get x is equal to minus 3, right? Minus 3 plus square root of minus 3 squared minus 4 times 5 times 1 in over 2a, so it's 2 times 5. So this is x is equal to minus 3 is positive 3, and plus or minus minus 3 squared, so that's 9. 9 minus 4 times 5 is 20, right? So it's minus 11 and over 10. So if there is a minus sign, okay, if there's a negative sign inside the discriminant, then we know that it will have like the imaginary number, right? It will have the imaginary number, so it's a complex roots. So we need to deal with this one. And 11 is not a perfect square number, and we cannot factor 11 anymore. So we just need to get I out of the square root. So then it's x is equal to 3 plus or minus I times square root of 11 over 10, okay? Because how did we get an I out of the square root of 11? It's because the minus 11 is actually equal to minus 1 times 11, right? So minus 1 is actually equal to I times 11. You see that? So this is the I square, so we can get the I out of the square root symbol. Okay, so that's how we get this outside, okay? And so x is 3 plus or minus I times square root of 11 over 10.
That's all for today, Rebels. Have a mathematical Monday.